The SD Ruby podcast is brought to you by New Relic.
So my name is Richard Schneeman. Schneeman is German for snowman, you might be happy to know. And I just came all this way to say hello.
Hi.
Super friendly. California, what a place. On the internet, I go by Schneems, and just part of my last name, so GitHub, Twitter, all those things, Schneems. A little bit about my background. I'm actually a mechanical engineer, so like probably a lot of you, I don't have a CS background. I know like some of my favorite coders are philosophy, economics, what have you. I've been coding Rails, Ruby for about 6 years now, going on 6 years now. I've got a couple projects under my belt. The Sextant Gem, if you haven't heard of it, it's super, super awesome. If you like run and use Rails regularly, you might be sick and tired of running rake routes. So this actually puts the contents of those in your browser, and instead of taking like 15 seconds to generate, it takes like 1 second. So yeah, and that's in Rails 4 now. We got that merged in, so use Rails 4 whenever that comes out. Also have a Road Wicked gem. It's for like step-by-step building things. There's a Rails.cache on it. And I work for Heroku. Anybody familiar with Heroku? All right, okay. So deploy your code, forget about servers, scale easily, effortlessly, Heroku. Also, I am an adjunct professor at the University of Texas where I teach database and Rails class. So yeah, hook 'em horns. Though the secret as to why I accepted the position was simply so I could say this. I mean, it seemed pretty reasonable. Also, I love tacos.
Yeah.
So Austin, Texas, tacos. I don't know. I mean, you all have some pretty good tacos too. Not gonna lie. So okay, today I'm here to talk to you about fast, going fast, being fast, and fast is kind of this nebulous thing. So we're actually gonna break it down into two separate components. We have speed, and then we also have throughput. So speed is just literally fast. It's Usain Bolt. It's space shuttles. It's T-Rex, and then throughput is how many of those can we get through at one time. So this is how many requests, how many concurrent requests can you get. So it doesn't matter if your web server responds in millisecond times if it can only take like one person every 10 seconds. So both are equally important whenever you're talking about getting things fast. Two common patterns that you're gonna run into are if you want to increase speed, you're gonna optimize and cache for speed. All right. For optimizing, we're going to be searching for slow, like pretty reasonable, and then we're gonna optimize it. We're gonna make it fast. For caching, we're going to search for expensive operations, and then we're going to make them cheap. Sound pretty reasonable?
Yeah.
Okay. You all have extensive background in Ruby Rails. There was a couple of you all I was talking to previously. Mostly Rails, some Sinatra, some JRuby. All right, seeing some nodding heads. When we're doing this, we can add capacity for throughput. That's going to get more requests through, and you can remember that both of them are always interconnected. So speed helps throughput. If you're getting more requests through per second, that's more people who can go through that pipeline. So the first thing we're going to talk about is speed. So it's what most people associate when they think of fast. One thing a lot of developers fail to consider is that there's a client-side speed and then there's a server-side speed. So the amount of time it takes for your response to render isn't the amount of time the client actually sees. So I got this from W3C. This is like the render stack of the page load cycle, and just this little section over here is the server side. That's the request and the response. We have TCP, we've got redirect, we've got prompt for all that stuff, and then everything after, it's all up to the browser to take advantage of. So the back end it's definitely important, but it's not all there is. So with back end speed, we're going to be mostly focusing on measuring. we're going to be looking for potential causes of slowness and inefficient code. One of the biggest culprits of this is slow I/O. So this is going to be your database. These are going to be slow queries. If you're talking to external services like maybe APIs, Facebook, GitHub, any of those are all things that can be slow, that can slow you down. So sometimes maybe it's the language. That was definitely the case in 187, where we saw like REE, and you can actually do some memory management tweaks, and you can say after every single page request we're gonna want to tweak the garbage collection. And also, as we're going on, we're seeing more and more emphasis being put on to Ruby in terms of speed, and like the VM's getting a little bit better. So those are all things you can consider. In general, the number one thing I look for in backend speed, if we're talking about database, is N+1 queries. So some of you are going to see this and be like, yeah, or like, come on, obviously, I do that. But for the uninitiated, we want to start off looking for N+1 queries with your logs. You might have some code in your app that looks something like this. Here we're pulling a product or some products from the database, and then we are iterating through each of them, and we're calling product.user. So for every single product that we pull, it's also going to execute another query. And like, I don't know about you, I've been doing this for a while, so I can kind of pick that out just like glancing at the code. But if I'm lazy, maybe not. But if I look at the logs, I see this as a huge problem. Like your entire page will just be filled up with user load, and so whenever I see that type of behavior inside of my logs, I say, okay, hey, maybe this is an N+1 query problem. And you can fix that with eager loading. Rails has something built in that we can just go ahead and we can upfront, we can say, hey, product, yes, I'm going to be grabbing lots of products, but I'm also going to want all of the users with that. So instead of N+1 queries, we have this nice little subquery. So it's, some people might say it's just as dense, but it's definitely much more performant. So yeah. Anybody have any questions with the eager loading subquery? N+1. Okay. We can also look for queries not using an index, and again, we're going to be using logs. Like logs are my favorite thing in the whole history of mankind whenever it comes to web servers. In your config /production.rb, you can specify an explain threshold, and if any query takes longer than that threshold, it'll actually automatically run an explain on the query to tell you how your database is actually executing that query. So if you have indexes, maybe it's not using those indexes. Maybe you're querying against two different things, you need a joint index. So whenever you do this and you look in your logs, then you can use that as a time to add some indexes. Above and beyond everything else though, I would highly recommend using monitoring software. So, New Relic is definitely one of the popular ones. You can just get all of your times broken down into different sections. You can actually see your individual databases and the GC time, Scout. There's a whole bunch of these. Also, even just looking at your logs and storing your logs, there's a couple of different services now. Like one of them is Paper Trails that I really like, where it just indefinitely stores X gigabytes of your logs, and then you can just use regular expressions to kind of parse through them. So sometimes that's helpful for debugging these types of slow issues, but also for going back and if you have a user-facing issue that you want to track down. Okay. So that is just kind of some raw, common optimization tricks. We want to be able to cache expensive queries. So sometimes you say, okay, I've got an index on it, I'm eager loading everything, my GC's maxed out, I'm on the most recent version of Ruby, most recent version of Rails, but it's still slow. So we have this query here, and no matter what, it's going to take 20 seconds using the benchmark library, if you're familiar. So Memcache, I love Memcache, it's fantastic. Super quick, super fast response times. If you're not familiar with Memcache, definitely go check it out. It's not that intimidating. And my favorite thing about Memcache is it actually plugs into Rails.cache. So Rails.cache is a standard interface inside of Rails that we can use to to actually cache different things. So here we call Rails.cache.fetch, and then we provide it with some key, and then inside of that block, then we run our query. So the first time that you run this, it's going to take 20.5 seconds, and then the second time you run this, rather than actually hitting that query or doing that calculation or whatever that was, it's going to just jump out to memcache. It's going to come back, and memcache is insanely fast, very, very fast. Like I actually think normally you get 0.000 something seconds. And this is the fetch pattern that the Rails cache is implemented, where the first time, if it doesn't exist in the cache, then it will go out and perform whatever is in that block. Of course, like the two most difficult things in programming are naming and cache invalidation. Because of that, I wrote a method cacheable gem. It's all the rage, where you can just add it into Rails and you get a cache method helper, and then instead of having to say fetch and put in a block, you can just call the method on it directly, and it uses the Rails cache layer underneath, so it's not doing anything fancy. So yes, we have a question.
I was just wondering if you're gonna have this deck. Is this online?
Yes.
On your website?
Yes, definitely.
Okay.
Also, I'm going to be available afterwards for questions, maybe beers. Yeah. Okay. So that was kind of the back end side of speed, just in a nutshell. Now I want to talk about throughput and some of the reasons why throughput is really important. You can take a look at, there's not a lot of publicly available data in terms of website traffic. Luckily Wikipedia does share theirs, and they get an impressive amount of traffic. We can see that the writes on Wikipedia is kind of going on this almost exponential curve, maybe leveling off a little bit, and the edits on Wikipedia are also going up. So it makes sense. The more articles you get, the more edits on articles you're going to get. The more people who use your service, the more, well, it's these compounding effects. It's definitely important to remember that if you don't keep up with throughput, then your speed's going to go down until a point where your servers literally can't handle it, and then you're just going to be getting a bunch of bad requests to all users. One thing that you can kind of help out with some of these things, especially in terms of reading, is view caching. So honestly, I'm going to say that view caching has never worked super well for me. The one thing that has inside of Rails is fragment caching. So Rails has a couple of different types of view caching you can do. You can cache an entire page, you can cache an action, or you can cache just one little tiny segment. And in my experience, the smaller of a segment that you try to cache, the better. 37 Signals actually just had Basecamp Next, where they basically publicized and very aggressively used a lot of fragment caching, and they actually had fragment caches inside of fragment caches. So one of the things that's going to be coming out soon is, or with Rails 4, the support for that is nested cache invalidation. Or if you're interested in taking a look at that right now, you can use the cache digest gem. So that's something to check out. All right, so while we're working on throughput, you're going to want to be able to split up your web, your workers, and your data stores. If all of those are running on one box, then it's going to be a little bit more difficult to allocate resources to one or the other. So when I say web, I mean this is any code that handles forward-facing request traffic. Somebody will type in a URL, it'll hit your server, and then it will return back HTML or JSON or whatever, depending on the type of endpoint. Your data store is going to be Postgres, MySQL, Memcache, any of those, preferably running on a completely different machine. So that way, if you say, oh wow, I'm like my web server is running fine, but my Memcache keeps on maxing out, you can actually just scale up your Memcache. And then we also have workers, which are becoming kind of first-class citizens with Rails 4, and we have the active queue. And these are going to handle non-request processing. So a good example is running rescue. It's maintained by Terrence Lee, recently, also works for Heroku, where you would in-queue sending an email. And this might be a process where it hits, say, SendGrid API, and you don't necessarily want for the user to actually wait for all of that to go back and forth. You can just throw this into the background. So workers, you can kind of take load off of the web side. Okay, so even if you do all that, you split everything out, you're going to eventually run into a problem. You're going to eventually run out of capacity, and then what do you do? So you have two general options if we're talking about throughput. You can scale up, so we're talking about more RAM, more hard drive space, more, what have you, more processors. In general, this is considered relatively cheap and incredibly simple. If you have a physical box, like yeah, sure, you have to swap it off, you have to turn off the box, but like actually installing, beefing up that box is considered relatively easy. Or you can scale out. So you start with one box, and then instead of adding more RAM to it, you just duplicate it out. So over and over, you add more capacity by adding basically more endpoints. Scaling up, generally easy, but kind of limited. At some point in time, you're going to run into a maximum amount of RAM you can have, maximum processor. You're going to have super, super crazy cooling systems and all that. So scaling out is generally considered pretty hard, but you can do it relatively unlimited. If you're Google, if you're Facebook, all of these services, they're not just sitting on one giant machine somewhere in like the Arctic to keep it cold. Maybe that's why global warming's happening. So one thing that you can do, or the number one best thing you can do in terms of if you want to scale out, is to keep your web machines ephemeral. And by this, I mean you're going to want to keep all of the state off of that machine. So if you've used Heroku before, then there's a Heroku PS scale where you can just say PS scale web equals 4, and then automatically we just go ahead and we provision you for compute units. What this would look like if you were using something like Amazon, AWS, you would provision a couple of extra units, and then you would use Chef or Puppet or whatever type of software you prefer, and then add those machines to some sort of a load balancer. So at the end of the day, it would kind of end up looking like this, where you have a central set of code, and then you push that onto multiple machines. So going back to the ephemeral side of things, if you're not storing state on the server, it makes this much, much easier. If anybody's familiar with some Java frameworks, maybe we have some Java web programmers, it was really, really popular where you would actually store like session data on disk or in memory. And so if I logged in to your site and I went to machine number 1, it would know who I am. But if we were going across multiple machines and I went back to machine number 2, well, it would try to read that from disk, and it's a completely separate disk, so it doesn't know how to find me. Generally, like most Rubyists are kind of like, really, why would you do that? So I think that's good. That's a good reaction, but just in case. You want to store data in your database. You can store data in your session if you want. Typically, Rails by default uses cookies. One thing to consider, every single time your user makes a request to your service, it's going to send all those cookies back. So if you're storing like a megabyte of data in the user's cookies, then that's going to slow things down too, because every single request you get, your server has to take an extra megabyte of cookies. So I generally try to stay away from the session as much as possible. Maybe some IDs, user ID, that kind of thing for authentication. Also, S3 is really nice. At the end of the day, what you want to be able to say is like, I can arbitrarily kill any of my web, or workers or whatever we're using, and it's not going to affect the user. Maybe like one user gets their connection cut off or something, but the overall experience stays up. So I mentioned workers previously. It's going to be pretty much the same thing. You're going to want to keep state off of those machines. You can again run rescue. There's also a couple other ones, delay jobs, sidekick. Has anybody played around with that one?
Sidekick or right-kick?
Sidekick.
Sidekick.
Okay. Just curious. So, I mean, that pretty much takes care of the request side of things. We talked a little bit about making things faster, then we talked a little bit about making sure we stay up. So, like, hey, we got on TechCrunch, we got on Slashdot, all right, fine, we know what to do, we'll add a few more nodes, we'll add some extra workers, we'll add some extra web units, but how do we store your data storage? Like, this has kind of always been one of the biggest cruxes in scaling out permanently and long term. So, there's going to be a couple of common patterns that you're going to see. Especially if you're using a relational database, one of the first ones you'll encounter is a master-slave architecture. So you have a master data set, and this is going to handle all of your writes, and then you're going to have a couple of slave machines that are just going to replicate that data to it, and then instead of reading off of your master, you're going to read off of your slave. So it actually takes load off of that one central server. So this is, if your bottleneck is read scaling, then master-slave architecture works great. Also, this is good for failover. So if you have even just one follower that on Heroku, you can just add a follower, and then you can fail over to it if you'd like. But I definitely recommend that in terms of data persistence and uptime. The next one is going to be sharding, and so master-slave will get you kind of there. It'll help you quite a bit, but sharding is really where it's at. But it turns out that sharding is really complicated. So we're gonna take a consistent type of data. So in this scenario, we have users, and we're gonna pick some sort of a subset, and we're gonna say, all right, how can we split these users up? Are the users coming from different organizations? In this case, a contrived example, just pulled them from different geographic areas, and they're actually going into separate databases. As long as the data from one shard doesn't have to interact with the other one, we're pretty good. The biggest limitation to this is that you can't join against that sharded data. So if you have split up your data, then you'll have to individually pull those records and kind of reassemble them. Because of that, quite a few services, or quite a few people who do this, end up actually creating mini services on top of that sharded data. And so rather than accessing the database directly, you would actually have maybe even another layer on top of it who would just say, like, join these things. If you want to know who shards, so Facebook shards MySQL. They use the MySQL database, and they have some documentation out there, or not some documentation, some press and talking about how they did that. Instagram actually shards PostgreSQL, and they have put a ton of data about exactly how they've done that, and that's really interesting. The biggest thing with sharding is you really have to understand your problem space before you do it. If you just go in and you say, okay, Rails new, and then the next thing is Rails shard, if that was a command. If it's not, I'm gonna introduce it tomorrow. It's not going to help unless you actually know how you're going to use the data, because if you shard incorrectly, it's going to actually be worse, or it's going to be more inefficient. So it might be scalable, but it'll be incredibly slow. In general, I recommend Postgres. I just love Postgres. It's like my favorite database. Yeah, fist pump. So the next thing, people, whenever I talk about scaling and sharding, everybody's like, hey, NoSQL, this is going to save the world, right? I mean, we've got MongoDB, and we've got Couch, yeah, Riak. Anybody Riak? Okay, all right. So no. It's not a magic bullet. A lot of these are designed for kind of newer needs, but just to kind of recap, if you're not familiar with NoSQL, I'm talking about anything that's not a relational database. So we're not going to be able to do joins. One of the most common types of NoSQL databases is going to be a key value store. An example of that would be Redis. So if you're not using Redis, I love Redis. It's fantastic. It's like almost a data structure server. It's great. And a lot of people, they'll get into Redis and they're like, I love Redis. I'm going to replace everything with Redis. I don't recommend that. Actually, one of the things I found works best is having, it's called polyglot persistence, where you might have some data in Postgres and then you might have some data in, say, Redis. And depending on what type of data you need, it might make sense to put it in one store or the other. So just if you're not familiar with Redis, we have a key, which here is foo, and then we have a value which is var, we can set it. Then later on we can say get that key, so we get foo, and it will return back to us var. I mean, pretty contrived data example. I worked at Gowalla for a little while. I don't know if you're familiar with that. Adam Key's a developer over there. We were a competitor to Foursquare for a while. We had Cassandra, we had Memcache, we had Redis, we had Postgres, and so I love this quote from him, just like every data store will punch you in the face. It's just a matter of knowing how it will punch you in the face. So if you know that, if I use Mongo, then I really have to watch out for my RAM and be prepared to maybe fail over, maybe provision some new servers, something along those lines. If you're doing key value stores, it's pretty easy to shard on key. You can do something called consistent hashing. So this is actually what Memcache uses. So you can imagine that we've got 3 different servers. We've got with Memcache, we've got server A Memcache, server B Memcache, server C Memcache, and we say, hey, store this value under this key, and we can take a hash of it to determine where that goes to. So if we hash that key and it comes in between B and C, it'll kind of just round up and go to the next one. It'll go to C. Or if we take a hash of it and it falls between C and A, then it'll just round it up. If I completely lost you, just Google consistent hashing. It's really cool, and it's kind of re-implemented in Memcache as well as some other ones. So whenever you need to add additional capacity to a system like this, you can just add an extra node, and instead of the data that may have previously been going to C, if we hash at a different place in our circle, then it'll just go to the next node. So consistent hashing is really convenient, but only whenever we have data. This is for volatile data. So with Memcache, you never put anything in it that you can't get from somewhere else. Things can fall in and out of memory in Memcache super easily. And never expect anything to be there. That's why the fetch pattern is so useful, because you can see if that thing exists. If it does, grab it from Memcache. Otherwise, don't. A pretty important thing inside of the NoSQL movement, or really any data storage, is CAP theorem, which I was introduced to way too late. So CAP stands for consistency, availability, and partition tolerance. So consistency, if we've got multiple nodes that are all supposed to be storing the exact same data, basically making backups of our data, do we want that? Availability, if one of our nodes goes down, do we want to say, no, we can't read? Or do we want to go ahead and say, yeah, sure, I'll give you whatever data I have. It might not be good data, because it might not be consistent across all the nodes, but I'll give you what I have. And then we have partition tolerance. So one really interesting database for this is Riak. So 7 databases in 7 weeks is a pretty good book. And one of the most interesting databases in it, to me, so far, has been Riak. They also mentioned Postgres and talk a lot about Postgres, which is it's still fighting, still in there. What Riak and a lot of these other types of databases will do is we say, okay, we want to write data. So we know we want to write data to node B, and node B says, well, wait a second, what happens if I die? What happens if my hard drive crashes or something? So node B is going to say, all right, well, we have a replication factor of 2, so I'm going to find the next node, which is C, and the one after that, which is D. And it's going to copy that data to those nodes. The really neat thing about Riak is, so that's not just Riak. Cassandra does something very similar. A lot of NoSQL that have multiple nodes and advertise that they scale out very well have that capability. That's pretty common. But what Riak has is it's actually it's a tunable cap, so tunable configuration. If you want, you can tell Riak, you can say hey, just write to B right now and give me an acknowledgement. So go ahead and give me an ACK. whenever you're done writing. I don't care when you replicate, just so long as you try to replicate. So that's tunable consistency, or it's tunable availability. No, I'm totally getting that mixed up. It's one of those. It's consistency or availability. You can also, so that's a tunable cap on write. An example of tunable cap on read would be whenever we query into our cluster and we say, hey, I'm looking for this key. Do you have it? And we can actually, whenever we say that, we can tell it, not only do I want this key, I want quorum from this many nodes. So we can say, I have to get this back from no less than 3 nodes to consider this data consistent. So yeah, React has configurable cap. I definitely see that going places. But again, really, there is no silver bullet in terms of any data store. Like, they're all going to have downsides. It's just the best thing you can do is educate yourselves on like the pros and the cons of what each one is good at. And also, like, if you have somebody who comes along and they're like, oh, this data store is like the greatest thing since sliced bread, consider that their needs for sliced bread might be different from yours. I think you followed me on that. Okay. All right, so that pretty much wraps up the server side speed. We talked a little about the speed. We talked about throughput. We talked about database access. We talked about scaling out and sharding master slave. So the next thing that I'm going to want to talk about is kind of the neglected thing from us. Most Rails developers, Ruby developers, we're kind of like back-end happy people. We're super happy to spend all day optimizing SQL, and it's like just because it's nerdy and it's fun. But there's actually quite a bit of latency and quite a bit of time lost in terms of the user experience from the client side. So previously I brought up this slide. So we've gotten past our TCP, our DNS, our request, our response. Now we're going to be actually looking at the processing and onload. It might seem pretty trivial because web browsers are relatively efficient these days, but a lot of people complain that they have Chrome open and it's taking up like 7 gigs of RAM or something ridiculous like that. It's because we put them through all sorts of special circumstances, and so anything that we can do to make their job a little bit easier is also going to help us by being faster. So assets. Who's using Rails 3.1 asset pipeline? All right. Asset pipeline has, all in all, I think it's a pretty good idea. Maybe has some implementation bugs to be worked out. One of the biggest caveats, or one of the biggest things in page loading, is slow assets. So as we're loading these assets, if they're coming in really slow, if they have to come in from your application server, it sounds like super obvious, but decrease the size of them. We can use gzip. There are lossless algorithms that you can actually run over a lot of your images that will produce just perfectly good images, but slightly smaller. Hey, everybody wins. You can also minify, so any of your JavaScript, any of your CSS, you want to minify that, take out all of the comments, and remember, every single time a page gets requested, it has to be sent. So the number one thing I actually recommend using, though, is a CDN. To introduce the concept of a CDN real quick, so speed is distance divided by time, and distance matters. If you decrease the distance you have to go somewhere, then you're going to get there faster. You're traveling at the same speed. So shorter distance is faster. If you are a user in South America and you have your servers somewhere up in North America, it's going that we're still bound by physics and the speed of light to make those connections. And I kind of wish it was this nice little straight line, but there's all sorts of routing and everything that it has to go through. So if we have multiple users connecting from multiple different places, they're all going to get different speeds from your website, from your web server. That's something to consider. So one thing that would be, like, in my ideal world, I would just be able to put a web server up and say, like, hey, everybody, just kind of clone off of this. And I would say, all right, South America, here's your web server, North America, here's your web server, and a lot of the big guys do this. If you're Google, if you're a large organization, you definitely have data locality where you have all your different servers in your different regions, but for a lot of Rails apps, it just doesn't make any sense. But luckily enough for you, we can use a CDN. CDN stands for Content Distribution Network. So this isn't going to distribute our code, but it is going to distribute our assets. So we can take our requests, and as we're looking for those assets, instead of having to go all the way back to our original custom server, so up here, up in North America is where I have my original server. This is where the original assets are. We can actually use these CDN servers in different regions to act as buffers. So users will get their data faster. It'll save on bandwidth, and we can use the CDNs to serve images, CSS, and JavaScript. So just our normal assets. The two most popular are Akamai and CloudFront. With CloudFront, you can just sign up on a credit card. Akamai, I think you have to I have no clue. I think you have to have a sales specialist call you or something. They're a little pricey. And CloudFront actually just rolled out some neat new features where they can accept cookies, and they also have I think cross-browser capabilities. So you can actually, if you wanted to, just run some single-page sites out of S3 and CloudFront. So. Yes, question.
I think they also just announced that you could pick places you really wanted to serve your stuff up at, and if they were, say you didn't really care about South America for some reason, you could opt out of that and save some money.
Yes, so because if we're looking at this, well, it was more of an announcement than a question, but I'll just reiterate with slides. Because we have spread out all of our data onto all of these servers, CloudFront actually has those servers there and has copies of our data, and that costs money to them. And if one of these is really, really popular, let's say the one on the tip of Africa over there is incredibly popular, but your user base that isn't in Africa at all, you can actually choose and say, hey, I don't really necessarily care about this zone, so I want my bill to be a little cheaper. So CloudFront now has the tunable kind of billing and availability. If you've never used CloudFront with Rails or any type of a CDN, there you go. That's it. So we in your production.rb, you're going to have config.actioncontroller.assetshost, and you're going to provide it with a CloudFront URL. Of course, you are going to have to you're going to have to sign up for CloudFront. It's going to give you a custom domain. It's going to be abcdgoldfish.cloudfront.com. And then you can set that in your environment. Heroku allows you to do something called configuration variables. So you could do Heroku config add CloudFront URL equals and then that URL. So what is going to happen is whenever your app is running in production, rather than telling the browser to, hey, grab this image app out of the Rails app, which kind of doesn't make any sense. Rails is pretty good, but it wasn't meant to serve images, and it doesn't have that data locality that we're looking for. So all you have to do is set this, and then it's kind of like magically with the asset pipeline, it just goes out and adds that URL. So it's getting it from CloudFront instead.
Quick question.
Yes.
So you mentioned the way that you can do it with Heroku. If you did it the way that you had it on the screen there and deployed to Heroku, would it work that way?
Yes.
Okay.
Yeah, so the question, yes. The question was, does this work on Heroku, I guess?
Doing that and then just deploying to Heroku the regular way through Git.
Yes, yeah. And the reason where the environment variable comes into play, which that's nice for me, is I have a staging server and I also have a production server, and the environment variable is going to be different on each server. And I actually have a different CloudFront account for each of those.
How do you know if CDN is working?
How do you know if it's working? You reload the page and you should see ABCD Goldfish. You could just view source and you should see instead of your images, it should be actually hosting off of the CDN. And CloudFront is, if you're familiar with Varnish, CloudFront is actually kind of behaving like Varnish, because the first time whenever you try to grab an image from it, it'll say, oh, okay, I don't know where this is, and I'm going to grab it from your actual server. And then after that, it'll cache it, which is, I don't know, it's super convenient. It's like one line of code. There are some caveats that we're going to get to in just a second, but we're going to get to them in just a second. This also helps out with browser caching. Whenever you have a browser, sometimes you might have been in kind of a scenario where you push something up to a server, or you're looking at a copy of the website and your friend is looking at a copy of the website and they don't quite work, or maybe like the image doesn't load and somebody says, oh yeah, force refresh your browser, forcing it to go back and actually pull out those assets and those requests. I don't know, it happened to me a lot. But browsers will actually do a similar type of caching like CDNs, or like we talked about with the memcache fetch. The first time you say, hey, grab me this JavaScript file, grab me jQuery, and it's going to say, all right, well, I don't have that, so I'm going to go ahead, I'm going to download it, and then once it does, it's going to store it locally. This is one of the reasons why Google provides CDNs for some of the really popular libraries is if you are spending time downloading jQuery if a user is spending time downloading jQuery on your website, then that's time they're not spending it downloading it on Google's websites. So it's like a win-win. And then on future requests, the computer is going to just use that local copy. The really important part with this, though, is we need to help the browser as much as possible by telling it how long it can keep a copy of that image or of that JavaScript. So here you're going to have to set your expires headers. And again, we can just go into our production.rb, and it's a simple we say our cache control is going to be public, so anybody can read from it, and then we just give it an incredibly large max age. Most likely a browser is going to just naturally garbage collect whatever assets we give it before it hits this. So the next question is, what happens if you do make changes? So you push up, maybe you have a jQuery file, you push it up to your server and somebody downloads it, they keep that cache. We can get rid of this by turning on asset fingerprints. If you're familiar with cryptographic hashes, that's exactly what an asset fingerprint is. We just set config.assets.digest to true, and it will take on the guides they refer to it as a fingerprint, and in reality they're just running MD5 over each of your files. So if we have a CSS file called headers, and we run MD5 over it, it'll with MD5 you can give it an arbitrarily large size of chunk of data, and it will give you back a consistent length string. And for the same piece of data, it'll always be the same length string. If you change it even just a little bit, the string will be wildly different. So we can take those two together and combine them to create kind of a fingerprint. So headers.css would actually become this. It would be headers dash and then the MD5 hash of headers.css. So whenever we take and we tell the browser and we tell the CDN, here's this headers file, it can just serve that for as long as you need it to. If you ever make any changes to that headers.css, the next time it gets recompiled, the next time it gets re-fingerprinted, it'll be a completely different file name. So that kind of is the workaround for that. And it's kind of like heavy-handed almost in a way, but if you already have the asset pipeline, then I think this is like 3 commands that I've shown you, and you've eliminated a large portion of headache and gain a lot of speed in the front end. All right, we can also measure to optimize. So we measure in the back end. We've got our logs. Everybody's big fans of the logs. On the front end, I like using a tool called YSlow. There might be other ones, and I'm not primarily a front end hacker. If somebody else wants to name a few, but this is yes.
I just want to mention, because it links back to something you said. New Relic has a end user monitoring that you can enable
Okay,
And,
so,
and it does basically inject a little JavaScript snippet at the top and bottom, and then it does profiling.
cool. So, for those that didn't hear that, New Relic has the front end injectable.
Yeah, I think they call it like real user monitoring.
End user scores.
All right, well, I'll rely on Google to answer that question over exactly what they call it. So also, even just Chrome by default has some diagnostics that you can run. I kind of like YSlow just because I was using it with Firebug like back in the day before like browser inspection was a thing, or like baked in was a thing, and it kind of gives you a nice human readable, like it gives you a score, right? So we can see and say, okay, we're doing a really good job avoiding empty source and href, and then maybe we can drill down a little bit and actually see some areas where we can improve. It's actually pretty surprising, some of the improvements that you can get in terms of actual consumer page load response. Of course, we want to compress assets. Asset Pipeline does this for us automatically. So we're going to be using Minify. We're going to be taking out white space. We're going to be taking out comments. We're going to be serving using a CDN, hopefully, something along the lines of CloudFront. It's pretty incredibly easy. Sometimes if you do run into problems, if you're using it and you're trying to debug, normally just running view source on a page and seeing the actual links that are being generated and clicking through to those is enough for me. Or even running rake assets precompile is something that I do pretty often. One thing that I thought was pretty neat that not a lot of people use or really even know about is async script loading. So we've probably seen the Google Analytics code before where it dynamically inserts an element to the page and then like on load it like adds extra scripts and stuff. Turns out you don't actually need to do that. The script tag with HTML5 actually supports an async keyword, so you can just add async into it, and at any point in time, as the browser is rendering this, it'll hit this script tag and it'll say, okay, I'm just going to go ahead and grab this. I'm not going to, normally, if without the async tag, it would actually pause your browser rendering. It would pause all the parsing that's going on, and it would wait until it had downloaded that because you might be modifying the DOM. But with async, you're kind of saying, I'm going to hold off on that, and we can just do it whenever we want. Question?
Or just put all your script tags at the bottom.
Yes. Well, definitely put all your script tags in the bottom. Even with that, I believe if you did that serially, like if you just said script tag, script, it would actually pause on each one of them and run each of them individually. You might want to double check this, but I believe async will actually run all of them concurrently. We'll actually download them concurrently, so that's kind of a huge win. If you...
It's not blocking, so it will start to download it, but it will continue execution to the next statement, so it's not blocking while it waits for that.
Exactly. So the async tag's not blocking. In addition to async, we also have defer. The kind of the biggest problem with async is it's non-deterministic. Even if you put a script tag in front of another script tag, it's not guaranteed to load before the other one. So if you had jQuery up front and then a bunch of other ones that were asyncly async on your page, then you can't guarantee necessarily that the jQuery was going to be loaded before. If you use defer, it will enforce that. So defer is going to guarantee order, and defer also has better IE support. Like both of those, not incredibly well supported. If you're dealing with a lot of Opera customers, then you might be kind of out of luck. But I think you'd be out of luck anyway. And the important thing is that they're not going to block your page parsing. All right, so at the end of the day, we are going to be wanting to measure everything. We can scale out with more machines. We can speed up your data store with queries, indexes. We watch out for those n+1 queries, and we can also add caching. All right, that's pretty much all I've got to say. I do want to mention if we do have a couple jobs available. Jobs.heroku.com. If you're interested in something along those lines, feel free to talk to me. And does anybody have any questions? MC Hammer notwithstanding. Yes.
What about speed of spinning up and staying up with Heroku? Are there tricks to not make that first guy who logs in the morning, wait for the spin up of my big old honking app?
The trick with that is paying us. So on all of our One Dyno apps, to decrease the overhead for us, because we still have to pay on the hosting. We put them to sleep. It takes them. We have to get them, read them off disk. That takes roughly about 10 seconds, and then add that on to whatever time it takes to actually boot up your app.
How long do they stay up?
They stay up for about an hour.
Cron job every 59 minutes.
That's right.
That last remark is going to be stricken from the record.
So, of all the things that you described that require like memcache or CDNs, does Heroku offer effectively add-ons for all of those ways to scale up and out and speed up?
So yeah, we have a memcache add-on. We've got a memcachier add-on as well, which is a competitor. With CloudFront, you will have to sign up separately. We don't have an add-on for it right now, and that's mostly all of our add-ons are done per usage time. So like if you use this for an hour or for it's a little bit more difficult to do with something like CloudFront where we would actually need to cut you off over a certain amount of they bill on a different way than we bill. Yeah, and we even have some of the NoSQL add-ons. I think we've got Mongo Labs support if you're interested in trying out Mongo. A lot of them also have a free tier. So if you're just interested in spinning up a site and saying like, hey, I want to learn something about one of these, one of these backends. Of course, you also have to be able to install it. I'm gonna save you all from the epileptic-inducing hammer time. Yeah, you also have to install them locally, and that's kind of just another thing. If you want to use memcache, you can do like brew install memcache, and then there's tons of good docs online for that. But really, I would say if you're looking for page speed, like the number one thing just across the board is like use a CDN, and which is also kind of convenient because it only takes like 3 or 4 lines of code.
And then if you're just serving, let's say, the United States with your app, is it still worth it to use CDN?
If you're serving event states, can
No,
you?
just the United States. Yeah, just the
Oh.
yeah, like if
CloudFront has regional, they have a regional
Yeah.
pricing. You can pick what region you want to supply.
Because I was just doing some tests here, and we have a server in the east and the west coast. So I pinged our west coast server, and we got about 25 millisecond. East coast is about 90, and Amazon was 15. So our west coast server's in San Jose.
Okay.
If I recall correctly, for Amazon, they got one up in the Pacific Northwest and one down near San Jose, and then east over in Boston.
Cool. Oh, and one thing I do want to point out that I guess I didn't mention on the original Heroku question, we don't scale. If you have more than one dyno, we never put you to sleep. So that's kind of a point of confusion. Like some people are like, oh, it's so slow to start up, but it's like, yeah. There's a question.
Yes, with the CloudFront and Heroku, do you need to deploy your assets to S3 or CloudFront, or?
Mm-hmm. So that's how it used. There's a couple of gems. I think Jamit is one of them, or S3 Asset Sync, that some people have used in the past. But CloudFront basically opened up the capability to act kind of like Varnish, where it says if it doesn't have the asset on CloudFront, it'll grab it from your machine. And Rails is smart enough to know that if we're telling it to as we're rendering to a page that a normal user would see, it's like it gives it a CloudFront URL. But if it comes from CloudFront, it'll actually serve that image or that asset. Yeah, like magic. Yes.
An asterisk on the fingerprinting stuff is to, if you're putting images in your HTML, to use image tag. You just randomly just shove like the path of the image, it won't fingerprint it, and you're screwing yourself. And then second asterisk is with CSS. If you're using asset pipeline to use, there's an image helper. So on your CSS, if you do css.erb, you can use the image helper. If you're using Sass, there's one as well for that. And it will fingerprint your images in your CSS. That's a big gotcha that people miss.
Yes, yeah. So use, I guess to recap that was use image tags in your CSS as well as in your HTML. If you're hard coding the images, it won't work.
Yeah.
Also for email, because like generally whenever you send out email, you always, if you send it out 5 months ago and somebody opens it this month, you still want those images to work. It will actually generate an unfingerprinted file that email will automatically take use of. So I mean, it's like all these nice little edge cases just already figured out for you. Go ahead.
Oh, I was just going to say, but the logic there, you're basing the file name off the fingerprint, and you never go on to the CDN to delete that original file. Shouldn't the file always exist, the old version of it?
So I think CloudFront will just. Oh, the question was if you never explicitly tell it to delete a file, and
like if you upload a file and you use the fingerprinting system.
Yes.
And it's got that fingerprint as part of the file.
Then
if you upload a new version of it, since you were saying it's technically a different file, that old file that the old email references or an old page references should never disappear. Unless CloudFront has some type of expiration.
So it's not necessarily. Rails doesn't guarantee, just because you're using Rails, can't guarantee that you're using some sort of a caching CDN. So they have to assume that any assets you're getting actually off of your server. So that's why they do that. I think CloudFront will just run some like garbage collecting if they see that something that nobody's hit this URL or hit this asset or image in a really long time, that they'll just clean it up. In addition to that, you can explicitly tell it to clean up or destroy files, but it's kind of a pain and it takes quite a while. You can do that through the AWS console.
Can you describe a little more about that nested fragment caching? You said it's going to be in Rails 4?
It might be in Rails 4. It's something that DHH kind of has put out there. I haven't played around with it too much, but the idea being, if you have a large page and maybe you have a sidebar on the page, and then inside of the sidebar there are it shows all of the collaborators on that page and like the number of comments that they've made. And so as you, like if I make a new comment, if that little cell for me was fragment cached, you would not only want to update that fragment cache, but if that was inside of a larger fragment cache, and that was inside of a larger fragment cache, you would want to go through and just like unallocate all of those. Yeah. So that's the gist of how it works, and I haven't actually seen it in use in practice. I just wanted to mention it if that's something you're interested in. And Basecamp has had, like, if you use Basecamp Next, it's pretty fast.
Varnish supports edge-side includes. I don't know if they go to the nested level, but like say it's like your home page, and the only thing that's different for users is like the little widget that says like their name, like hi, whatever. You can cache pretty much the whole page, and then just request that small piece. Varnish will be smart enough to do that.
That's cool.
Yeah, it's like the opposite of fragment caching almost, where you're caching the majority and you're pulling a small piece.
Donut instead of the whole.
Yeah, there's also a Rails.cache on where he goes through and Ryan Bates goes through and shows how you can just cache the whole page using just page cache, and then update sections using something like JavaScript. But that's a little bit. And anytime you get into caching like really, really, really large things, you always end up running into like edge cases where you're like, oh, I'm sure I can cache this page, and then you realize, oh yeah, there's a username on it, and like, you know, when I log in, I don't want to see like my sister's username.
That's just weird.
I mean, unless I do, I don't have to think of it.
One of those could be security issues.
Yeah, oh yeah, definitely. Like cache invalidation, like genuinely one of the most difficult things ever.
We did a lot of fragment caching on a site that we were doing, and it cut the speeds way down. But some of the things that we did for the invalidation was using things like the views, even like the timestamp in the view, or sometimes we had some automatic stuff in there that would tie in and look for MD5 content of the view, look to see if anything had changed and stuff like that. And that way it would invalidate itself, and we wouldn't have to proactively, we'd forget a lot until we did this. So if we change anything about that view, it just took care of itself and everything would be invalidated automatically. So that helped a lot. I wanted to ask about with the assets, you're talking about the fingerprinting. Is there a major difference between using the fingerprinting as part of the file name and change the actual file name versus tying like a query string onto the end of assets file name?
So that the question, if you have been using Rails for a while, you've probably seen like assets will have a query string and then just like a question mark and then like the fingerprint of the file name on it. That isn't supported everywhere. Not all servers support that. Not all browsers support that. It just so this was kind of like the nuclear option to like, because literally it is a different file.
You force it.
Yeah, basically. So you're almost kind of taking the implementation out of the browser, just being like, please, whatever you do, just cache this. Like, cache it for as long as you can. Take this, hold on to it. It is dear to you.
I actually just tried the query string cache buster with CloudFence today. It did not. 30 days.
I thought they added support for.
Maybe there's some checkbox here.
Yeah, that's always the one thing with. I mean, dealing with CDNs, you're inherently dealing with cache data, and it can be a little tricky to troubleshoot sometimes.
I think most logic there is from like mid-tier proxy servers that will be caching stuff. For instance, like some like ISPs will cache popular content and such. And the idea is that if it's got a query string on it, there's the ability that it could be personalized personal information because it's actually a server responding to a specific request as opposed to a public request. And so they just across the board, a lot of them are set up to just not cache anything that has query strings.
Okay, I didn't even know that. To repeat why don't you come up here? So to repeat, a lot of ISPs will consider that if you've got a query string on the end of the query, that it's going to be a personalized piece of data, and so it's not going to cache it. I think. Is that?
Yeah.
Okay. Cool. All right. Yeah. Like I said, I'm going to be available for pretty much the rest of the evening. I think we're going to go out maybe rock bottom, and so if you have any questions on stuff in Rails 4 or like routes, that's kind of like my jam. Or Heroku, I'm definitely open to that. Or if you want to know the difference between like Austin and San Diego tacos, like we can.
Breakfast tacos.
Breakfast tacos. You don't know what you're missing.
Thanks, Steve.